Welcome to another session of Stop, Look, Listen, and Learn. Today we're going to be discussing measuring interest rate risk, and we're going to be looking at two popular metrics that fixed income managers use to measure and quantify interest rate risk. The first one is DV01 and the second one is KR01. So let's jump right in. So the first thing is interest rates have a significant impact on the value of fixed income securities. And as a result, managers must be able to quantify and manage the impact that changes in interest rates will have on their fixed income portfolios. And portfolio managers typically use many different metrics to quantify and manage the impact that changing interest rates have on their fixed income portfolios. DV01 and KR01 are two metrics that are widely used by portfolio managers of fixed income securities. Now, let's start off by doing a little bit of level setting. So here we want to start off by looking at how fixed income securities are valued and the role that interest rates play in the valuation of fixed income securities. So first off, we need to acknowledge that there is an inverse relationship between the value of a fixed income security and the level of interest rates. So as interest rates increase, the value of fixed income securities will decrease. Also, there are many different interest rates that can be used to value fixed income securities. So for example, we have spot rates, and spot rates can be derived from the par rate curve via the bootstrapping process. And I have another video that discusses that bootstrapping process, and we'll also look at how that bootstrapping process works here in this video. Also, you have forward rates, which can be derived from the spot rates, and you have yield to maturity, which represents a weighted average of the various spot rates. So each of those three rates can be used to value fixed income securities. Now, there is not one interest rate, but there's a number of interest rates, and you have what is called a term structure of interest rates. And all that means is that you look at the term of the fixed income security and the interest rate associated with that particular security. So you may have a fixed income security that has a term of 2 years, it would have a certain interest rate. You look at a fixed income security that has a term of 5 years, it would have a certain interest rate associated with that. And so what you see is that there's this relationship between the term of the fixed income security and the interest rate. And normally the interest rate curve is upwardly sloping, meaning that the greater the term of the fixed income security, the higher is the interest rate, right? Now, when you're looking at changes in interest rates, the interest rates can change in a number of different ways. So we usually start off by considering parallel shifts in the interest rate curve. And so if you look at the middle box here, you see the black line that is slightly above the red line. And what that black line represents is a parallel shift in the term structure of interest rates. In other words, each one of the spot rates here increased by the same number of basis points, and hence the line just shifts up and the slope doesn't change. But that's not always the case. In fact, very rarely will the interest rates change in a parallel fashion. Usually different rates along the curve will change by differing amounts. And the box or the chart on the far right shows you how the term structure can twist and turn. So here we have rates on the shorter end that are decreasing and rates on the higher end that are increasing. And so you get a twist or a turn in the term structure of the spot rates. And so those changing interest rates will have an impact on the value of fixed income securities. And that's what portfolio managers have to be able to quantify and manage, right? So now, continuing on with the valuation of securities, as I said earlier, there is an inverse relationship between the value of a fixed income security and the level of interest rates. So you see the curve line here, that represents the actual value of a bond. And you see down on the horizontal axis, you have changes in the interest rates. So if we start off in this middle, at this middle point here, we have a certain interest rate and a value of the bond. And if those interest rates were to decline or move to the left, you see that the value of the bond increases. And if that interest rate were to move to the right, then you see the value of that bond will decrease, right? But it's not a linear relationship in terms of the actual change in the value. So it's a curved relationship, and that represents the convexity. Now, you see the dotted line there. The dotted line there represents the duration or the projected change in the value of the bond for a small change in the interest rates. And so you can see if the change in interest rate is relatively small, then that dotted line tracks pretty closely to that curved line, and it provides a pretty good estimate of the change in value of the bond that would be occasioned by a change in interest rates. Now, if the change in interest rates are large, then you see that dotted line starts to diverge from the curved line, which represents the actual value of the bond, and that's because this is a first order or linear approximation of the change in value. And so if the shift in interest rate is pretty high, then we're going to need more than duration. We'll need convexity as well. And that difference between the dotted line and the curved line, you can see as the change in the rates increase, that difference gets larger and larger, and that's what we refer to as the convexity of the bond price with respect to interest rates. And so in addition to calculating the duration, we'll also need to calculate the convexity of the bond as well, right? So that's just a general overview of the valuation of securities, right? Now, if we go to DV01, now DV01 basically quantifies the impact that a 1 basis point change in an interest rate will have on the value of a fixed income portfolio. And just to illustrate this, we assume that we have a portfolio consisting of a treasury bond, U.S. Treasury bond, with the following features: a face value of $100,000, a coupon rate of 8%, and a time to maturity of 3 years. And the question is, what impact will a parallel shift in the term structure of the spot rates have on the value of this bond here? And so we can see how the spot rates shift up, are shifting up, so we have a parallel shift here. So if we go here, first thing we want to do is we want to value the bond using the current term structure of spot rates. And so that basically means we take the projected cash flows at the various points in the future, so 6 months, a year and a half, 2 years, 2.5 years, so on and so forth, and we apply the spot rate that applies to that particular term, and then we discount those cash flows. And when we do that, we see that we get an initial value of $103,428. And then what we want to do is we want to shock the spot rate curve, and in this case we want to have it to shift down by 1 basis point. And if we assume that it shifts down by 1 basis points, we get the new spot rate curve here, and then utilizing those new spot rates, we value the same bond because the cash flows of the bond will remain the same. We're just going to be discounting them at a different rate. And when we do that, we see that the new value of the bond changes from $103,428 to $103,455. So as you can see, if the rates drop, then the value of the bond goes up. And in a similar fashion, we'll shock the term structure of spot rates up by 1 basis point, and we'll use those new spot rates to value that bond again. And as we see, when we do that, the value of the bond changes from $103,428 down to $103,402, and that represents a change of $26 and basically 42 cents, if you will. And when we shock the rates down, we get an increase in value of about $26.42. And then essentially what we do is we take the average of those two numbers, as sum them up divided by 2, and then we get the DV01 metric, which basically tells us that if we have a portfolio consisting of this one fixed income instrument, and if the term structure of spot rates increase in a parallel fashion by 1 basis point, then the change in the value of that portfolio would be $26.42. And so that's basically what the DV01 is telling you in a nutshell. So if we go back to the slide here, we see if we start here, and then this point on the interest rate curve will essentially be the weighted average of all those spot rates, right? And then if they change in such a way that this moves just a little bit down, then we see that the value of the bond increases a little bit. If it moves up just a little bit, so a parallel shift up, we see that the value of the bond comes down. And what the DV01 does is it enables us to quantify the change in the value of the bond for that 1 basis point shift up or down in the term structure of interest rates, right? Now, if we move to KR01, that relates to the term structure of the spot rates, but some spot rates are more important than others. The more important spot rates are referred to as key rates. And the term structure of spot rates, as I said earlier, rarely change in a parallel fashion. There's usually some kind of twist or turn as depicted by this graph towards the bottom of the page. And that means that different spot rates change by different amounts, and you still need to be able to quantify the impact on the value of your fixed income portfolio when this term structure spot rates twist or turn, if you will, right? And so fixed income managers oftentimes will what they want to do is they want to understand what impact will a 1 basis point change in various key rates have on the value of their fixed income portfolio. And this is best explained by walking through a simple example here.